Welcome to today's webcast, brought to you by Datavail. I'm Stephen Faig, Business Development Manager at Unisphere Research in Database Trends and Applications. I will be the host for today's broadcast. Our presentation today is titled, A New Framework for Solving Database Performance Issues. Before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response to it within a few days. We will also have a polling question to start the event. Please take a moment to select your answer, and we will show the results live during the event. And there is a survey we would like you to take. The survey widget is at the bottom of the screen to the far right. You can fill this out at any time. Finally, if you'd like to tweet live during today's show, simply sign in through the widget. There's also a white paper available on the topic of database performance in the resources section. And one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if you're the winner. Now, to introduce our speaker for today, Chuck Ezell, Senior Applications Tuner, Datavail. For more information on our speaker today, you can click on the Bio tab on your console. Now, on to today's poll. What platforms are you currently operating on? Oracle, SQL Server, DB2, MySQL, Sybase, or other. You can select more than one, and if you select other, please type your answer into the question box provided. Plus, remember, you can ask questions throughout the presentation, and we will try to get to all questions during the event. But if your question has not been selected during the show, you will receive an email response to it within a few days. Now, let's look at the results. What platforms are you currently operating on? 66.6% have Oracle. Coming in a close second, SQL Server with 62.5%. DB2 represents 8.3%. MySQL 4.1%. No one's using Sybase, and no one's using anything else. Now I'd like to pass the event over to Chuck Ezell, Senior Applications Tuner, Datavail.
Hey, everybody. Glad you've taken the time to tune in today, and I'm really excited about talking about these concepts and looking at database performance tuning. So if you will, make sure that you respond to that poll. So it looks like actually that the majority of people are Oracle SQL Server, so that's good. I'm hoping that I can, as I go through this, be more specific to the particular platforms and speak directly to what might be optimal for each one. So a few things before we get started. These concepts will apply to a relational database. So if you are working in Hadoop, or if you have other databases, they're like a NoSQL or Cassandra or MongoDB, these concepts might or might not apply. This is really more so related to relational databases. And, so many people ask me, how do I do database performance tuning? What do I look at first? How do I approach it? And so I'm hoping that today, as I've tried to formulate everything into something that is a little bit more memorable, I hope I can help you get started if you're not already doing this, or maybe even clarify some of the things that you might already be doing, and maybe you can skip some of the mistakes that I've made earlier in my career. Another thing is that we're going to avoid all the technical details. I'm not really going to give you concepts on how to partition tables. I'm not going to get into, how to create indexes. This is really more so us talking about how do we approach database performance tuning. So let's get started. So this is the landscape that we are facing. Bank of America Online was down for 6 days, affected 29 million online customers. Gmail was down for 2 days, caused by software updates affecting 120,000 users. Virgin Blue's reservation desk was down for 11 days and affected 50,000 passengers and 400 flights, and it cost millions in profit. Netflix was down for 4 to 8 hours. It affected 20 million customers, and potentially it was due to some software deployment issues that they termed as internal technical issues. PayPal battled on and off service outages for about 5 days in October 2004 after they upgraded their site, and they blamed the glitches on this software update that they did. So whether we're talking about Bank of America or Gmail, Netflix, Intuit, BlackBerry, Amazon, Yahoo, all of these customers, all of these companies face performance issues. And many times we're dealing with reactive fixes, and I know you guys are probably facing these issues every day. So what's our methodology? What's our approach? How do we fix these things that really surprise us? Because most often our performance problems are not related to installing a whole new database environment or brand new hardware installs. Many times there are just daily things that happen, changes to the movable parts, if you will, in the database. Things like application code changes, data model changes, data growth, configuration changes. So why do we performance tune? This is an obvious question, right? 80% of the unplanned outages that many companies face are due to ill-planned changes made by operations or developers. Things like new code or tables or indexes that are pushed in, but they were not tested in some type of pre-production environment. 60% of availability or performance errors are the result of misconfiguration. Things like a schema permissions that were not added. 80% of the incidents are often caused by changes made to the IT environment, including application code. Things like they pushed out a new SQL, new store procedure, or we didn't add the column to that particular table, or we didn't increase the varchar limits, whatever it is, these things are causing problems in our production environments. And, looking ahead through 2015, 80% of the outages that impact mission-critical services will be caused by people and process issues. More than 50% will be caused by change, configuration, release, integration, and handoff issues. So here's the key here. People and process. When we talk about changes and we talk about IT environments, we talk about database performance, they don't stand alone. People touch these environments, and there are a lot of moving parts, and there are a lot of things to look at. There are a lot of potential problems, and so often these things are not predictable. We don't have a guide. We don't have a 10-step process to making these things better, and we can click a button, like the Staples button, and it's easy. We don't have that for our database. So how do we approach these problems? How can we deal with these performance issues? We need a process, or we need an approach. Even if we have tools, even if we have tools that we use, they often just provide insight. So how do we approach our problems? So we tune through people and process. I came across this just a few weeks ago. This DBA is asking Tom, if you're familiar with Ask Tom at Oracle, they're asking him, can you give me a methodology of tuning the SQL statements? And I thought his response was perfect. So here he responds, and he says, if you want a 10-step guide to tuning a query, buy a piece of software. You're not needed in this process. Anybody can put a query in. Anybody can get a query out. They can run it to see if it's faster. There are tons of tools on the market, and oftentimes they work using rules, and they can tune maybe 1% of the problem queries out there, but they appear to be able to tune much larger, but it's oftentimes because people aren't really going back and looking at the outcome. Hence, they continue to make the same basic mistakes over and over. And then he concluded this with, I think, a really important statement. If you want to really be able to tune the other 99% of the queries out there, knowledge of lots of stuff, physical storage mechanisms, access paths, how the optimizer works. That's the only way. See, we have to have knowledge of our database environments, right? And many of us have it. We know how the thing is architected. We know how it's installed. We know how it's implemented. And so if we have this knowledge, what do we do with what we find? We can fix all day long, right? We can put the fixes in. We can patch our environment. But how do we find where the problems are? So our key is really our approach. Do you remember the movie The Sixth Sense with Bruce Willis? The first time I saw that movie, I thought, Bruce Willis has he's got some issues he needs to be working out with his wife. Here he goes and he sits down at the restaurant, he speaks to her, he's late, maybe that's understandable, maybe it happens all the time, but man, she doesn't even look at it, there are presuppositions that I made about that movie. It wasn't until the end that I realized that he was a ghost. She didn't see him. So we can oftentimes make presuppositions. We can make assumptions about our environment, based on what we think the problems are. So what we need really is an approach. So if we could condense all the problems that ever occur in all of the database environments, if we could condense those down into a chart, what would that chart look like? How wouldn't that be a help for us? That would at least tell us where do we go first to look. If we have a performance issue, what's the first thing to start looking at, right? So, I came across this question by this young DBA on Stack Exchange. And they're asking this question, what are the top 3 performance issues that you encounter with your SQL servers? So what I did is I took all of their responses. All of these DBAs are responding with their top 3 performance issues. And I categorized these, each one, into major categories. And then I summed them all up. And here's the way it looked. 33% said that their performance problems were oftentimes happening in the SQL code. 27% said it was indexing. Then there's another 20% that said it was architecture or data modeling, and then the final 20% broke out into statistics or sessions. So, this is validating to me because this is what I see. This is what I see when I look at different production environments. I'm constantly looking at multiple customers, multiple implementations, multiple configurations, and oftentimes I see very much the same thing. So it was validating to me to see this. And so these are our major issues. But how do we approach these issues? What do we look at first? We really haven't answered the question about the approach. We can kind of look at this and say, okay, well, maybe we should do a better job of monitoring our SQL code. Well, how do we approach performance tuning the code? How do we approach performance tuning indexes? So let's talk a little bit about what database tuning is. You've probably heard, if you've been in IT very long, been a DBA manager, you've been in a DBA for very long, you've heard things like this. Pull an AWR, pull an Ash report, right? Let's look at the workload history. Maybe we'll find something there. Or even questions like this, what's your buffer cache hit ratio? Or are your statistics up to date? And here's the thing. I'm not mocking these at all. These are valid approaches, and these are the way to go when you need a broad understanding of what's happening in your environment. But many times these are high-level, broad approaches. They deal with the symptoms and not the cause. So this lower half area here, these are just some random things I'm throwing in here. These are symptoms that we see, right? We pull a report and we see things like high sequential reads. We see I/O wait. We see high buffer gets. We see this cursor pin S wait on X. What are all these things, right? I mean, early in my career, I got so caught up looking at these, trying to figure out, well, why do I have such high I/O? Why do my buffer why are they so bad? And I would spend so much time looking at these symptoms, these peripheral issues, that I rarely would get to the root cause of where the problems really, really were. So we've got all these peripheral things. We've got these reports. We've got all these things that we can look at, but they tend to be very broad. So how do we get to the root cause? It's kind of ignore the forest for the trees, right? I mean, every defect is a treasure if the company can uncover its cause and can work to prevent it across the corporation. It is a treasure. However, we have to be reactive in uncovering these issues. We have to dig and find these problems, these root cause analysis, right? We have to work to prevent it. We have to be proactive in how we approach these problems, answering the questions and dealing with the problems before they occur. So whether we're talking about a reactive approach or a proactive approach, so many of the approaches that I have seen and found, and even the ones that I started with early in my career, were really from a hardware architecture perspective. You know, they kind of dealt with these peripheral issues. And they were kind of distractions. You know, look at this or look at that, and it tended to distract me from really digging down into the root cause. So here's what I've discovered. What works in reactive situations often applies when you're proactively planning, because in both cases we're mitigating. Most often, the reality is that we're facing reactive situations, right? We're dealing with something that happened, and we're trying to put that fire out. So how can we build on what we know are real problems that we're fixing right now? How can we avoid all of the distractions of the potential peripheral issues? Because what we really need is a direct way to address root cause and then remediate. So let me share with you what this 5S approach is. It's really a mindset. It's kind of how I have learned to do tuning. It's how I've learned to deal with database performance issues. So many times the first thing I look at is the SQL code, because when it comes down to it, it really is about the SQL running in your environment, right? This is a movable part. This is something that changes. Sometimes it changes often. It really depends on your environment. But I look at the SQL code, and depending on the execution plan, it might lead me to kind of begin to dig a little deeper into statistics, or why is the execution plan doing what it's doing? And then I might look at space or indexing. You know, what type of objects is it addressing? How are those objects managed? Are they healthy objects? If all of that looks good, then, I might actually switch gears, and I might begin to look at sessions. Are there too many sessions running? Where are the session problems, or the locking, sessions causing other locks and things like that? And then, of course, I'll look at scheduled processes. Is there anything going on that's conflicting with this particular statement running right now? So this is the 5S approach: SQL code, statistics, space and indexing, sessions, and scheduled process. So it's not really a process per se. It's not really it's more so a mindset, all right? It's a way that you can begin to say, okay, what do I look at first? How do I deal with the problems that I'm seeing? Because I need to know root cause. I need insight into why, because I need to remediate this code. How do I measure the problems that I'm seeing? I already have this tool. I have OEM, or I have Toad, or I have, SQL Server Analyzer. I have these tools at my grasp, but how do I make better use of these tools? So let's dig into each one of these categories a little bit, and let's talk about the kind of things that we typically see. The first thing I do is I'll look at the SQL code. I'll look at the execution plan, and I'm asking questions like this. What are the peaks? What are the bottlenecks? I might look at the indexes that are being used. Do I see things like index skip scans? Do I see index range scans? Do I see full table scans? These can be problem areas. These will be bottlenecks. How can I eliminate these things? But first, why is the optimizer choosing this index instead of the other index? Because I know that there are other indexes that it could be using. So why is the execution engine generating this plan? There might be something in the code like an embedded hint, for example, that is forcing this poor execution. You don't want things in your code that say, hey, use this index because 2 years from now that index might be gone, that index might be poorly implemented, that there could be problems with the hint. So why is the execution plan doing what it's doing? And then I might actually review the particular SQL, right? You dig down into the code and you look and you see, are there wise uses of the optimized core language functions? For example, if you're running SQL Server, you want to make sure you're using T-SQL for all of your conversions. You don't want to use things like ANSI SQL or generic SQL because sometimes there are database environments that will not handle the ANSI SQL nearly as well as it would handle Transact SQL or PL SQL. You want to make sure you're using core product-friendly functions, that you're not doing things like ANSI joins. You want to make sure you're using core product-friendly joins. And then I'll ask other questions like implicit conversions. Do I see strange date or integer calculations that could be done better? Are there too many rows being selected in the SQL? Select star, for example. Of course, we don't want to see selecting everything from the table. We want to see particular columns selected or fields selected from. Other questions like, are there bind variables being used? Our modern relational databases will actually capture that SQL and it will cache it. It will maintain the plan, and if there are bind variables, then it will run that same one over and over. And so that can help us. It could hurt us. If there aren't bind variables being used, then it might have to regenerate a new execution plan every time. If they are being used, it might be using the same poor execution plan every time. So we look at bind variables. And then other things like iterative calls. Is it generating multiple SQL statements? These kinds of things could be and should be reduced. So we look at the SQL. Where does that lead? Oftentimes leads to ask questions about statistics. Are our stats up to date? Are we making sure that the statistics, essentially the digest or the summary of what's in the table is accurate? Are we finding stats on things like temporary tables? Like you don't want stats on temporary tables. And I've seen this in environments where you've got a temporary table, and the whole concept of this temporary table is to grab a bunch of data, put it into the temporary table, do your manipulations on it, do your calculations and massage that data, and then take it back out and push it into where you want it, its final resting place. Then you want to truncate that table. But if there are statistics on temporary tables, it could skew the optimizer. Right, so the execution plan might be thinking, because of the statistics, it might be thinking that there are 10 rows in this temporary table, but there are really 10 million rows because at runtime, that table's populated. So you don't want stats on your temporary tables. Other questions like, is there a great degree of data manipulation? So are there a lot of inserts, updates, deletes, right? Has it left this high watermark? And I think for me, the best analogy for a high watermark is kind of like that the old laptop batteries of the 90s. When you first got that laptop, it worked great. You might get 30, 40 minutes of time, but eventually as you recharged it over time, it would develop this memory. And it might only last 5 minutes, and then you just have to chunk the battery, get a new one. And it's kind of like a high watermark, right? There's a lot of data manipulation, but if the stats are not managed well, it can be confusing to the optimizer, and it will choose things that are probably less than optimal. Are there sufficient transaction slots for the table or index in question? You want to make sure that all of the SQL can access these objects when they want it. Right? You don't want to see locks and other things that occur, so you want to make sure that they're highly available. What is the clustering factor on the indexing question? Different the difference between how the rows are organized in the data can make a big difference in how the execution plan or how the optimizer makes a determination of what to do. So then I might begin to look at the indexes, kind of asking questions like, are there better indexes that can be used? We have all of these indexes. Why is the optimizer choosing to use this one instead of the other one? Because I know the other one will be right? So we would kind of begin to look at things like range scans or skip scans and try to feel out or figure out why is it choosing this one and skipping over all of these columns in order to do an index, a skip scan. Are there missing indexes, right? Are there indexes that should be there, but they're not? We're seeing a bunch of full table scans, for example, and we need indexes to eliminate those guys. So maybe we have too many indexes, and there's a lot of I/O going on, and these indexes become very confusing because they're all very, very similar. Is there too much data in the table? So when we begin to think about space, and we begin to think about how much data do we really need to retain? Do you really need 5 years worth of data in these tables? Questions like that. Do we have an archiving and purging plan to eliminate this data so that we make our objects more optimized? Are the tables fragmented and in need of rebuilding? Do we see a lot of scattered reads? If so, it's possible that we have a lot of fragmentation. So we recently did a table reorganization or table reorg on one of our customers' environments, and we recovered over 700 gig of storage. That's about a third of their total storage. So just by reorging the tables, we were able to recover and optimize their environment. So space is a big deal. And is there sufficient space available, right? Do we have enough space available for headroom, for temp data, and everything else to be processed? So then what? So then we've kind of looked at the SQL. We've looked at the code. We might have dug into it a little bit and determined, is the code written well? Are we using vendor options? Are we using optimized functions? Are we using things that will help us generate wise and fast execution plans? Are our stats up to date? Are our indexes appropriately used? If we've answered these questions, a lot of times the next thing I might begin to look at is sort of step out of that and then look at sessions. Then I might begin to look at what else is running right now. Is it possible that a developer is testing SQL code against production? I've seen it. It happens. We don't want to do that, right? So other things like long-running sessions that cause blocks or waiting. Other sessions that are locking objects or possibly invalidating objects. Are we seeing too many sessions? Or are we seeing abandoned sessions, right? We have a particular environment that we're working with right now that has multiple abandoned sessions. And so what you could have is this compounding problem. So let's see, a scenario might be where you have a slow SQL execution. There's maybe one or two slow statements, right? And there's an insert statement going, and it's inserting data. But while it's doing that, it's locking multiple objects in order to update that data. And until those locks are gone, then it's going to hold up everything else. And while it begins to hold everything else up, the application begins to slow down. People begin to log in. The pages are operating slowly. They close the browser. They log in again. They close the browser. They log in again, and they're instantiating all of these multiple sessions. So one problem can lead to another. But if we make assumptions about the environment, we might be thinking, oh, well, this is a log writer problem, right? This could be a problem with our disk storage. We have to be careful not to make assumptions and make sure that we're really approaching the problem from the right perspective. Other simple things that can be done, scheduled processes. That might be the fifth thing I'll look at is things like the backup. Was the backup scheduled for AM or was it at PM? Right in the middle of the sales day. Oops. It happens. It's a simple mistake, but it can be a big problem. Are there other processes competing for the resources that we need? Do we know how many child processes what we have scheduled will spawn? Sometimes we schedule a particular process, and it might spawn multiple child processes. So we have to make sure we understand what we're scheduling. Are we updating our statistics during a time when other activity is occurring? We want to be careful that we're not conflicting, because when we do that, we can lock objects, we can lock indexes, we can lock tables, we can lock these things, and then no one can access, no one can update, delete, we can cause problems with these scheduled processes. So let's do this. Let's look at some case studies, and let's see how this approach might actually apply to real-world scenarios. So case study 1, the customer's environment was Informix, Java, Silverlight, and their complaint was simple. The reports were running greater than 5 minutes. But it only happens when they're searching for city, state, zip, vendor name, or vendor ID. It's kind of a strange situation, it seemed. So what we did is we profiled the code, and we actually started at the application level. And we looked at the Java. No problem with the Java. Looked great. No problem with the Silverlight. We found the problem, and the bottleneck was in the SQL code. So we pulled the SQL code out. We began to really look at it, and what we found was that there were too many ANSI joins to this external database where they were getting vendor information. We found that the SQL was using this OR statement in the joins against two different sets of tables. Because the normalization was so high, it forced these multiple joins just to select the simple vendor information. So essentially, there was poor, non-standard SQL that caused Informix to generate the bad execution plan. Let me say something about normalization. Normalization is an ideal. It's a great concept. But we have to be careful that we're not normalizing our data down to the third formal norm, the fourth, fifth, sixth. It can be taken too far. So we need to stop normalizing where we find our performance peaks, right? We don't want to begin to separate chunk data out to pieces, because not only are we causing a problem with our data model accessing the data itself, but we're creating more objects that have to be managed. So normalization is great, but sometimes it can be a problem. So our solution in this scenario was to replicate the external dependency into a denormalized table within the database, within the particular one that we were optimizing. And that allowed us to rewrite the SQL joins. It allowed us to eliminate the OR clauses because we denormalized the data. The data wasn't beautiful when we were done, but it's not about beautiful data. It's about getting to the data. It's about response time. It's about making the application optimized. So our result was a 5-minute response time that decreased to a maximum of 30 seconds. Case study number 2. The environment was Oracle EBS and iStore. And the complaint was that the vendor sales checkout form was performing slowly. And what we found, the root cause, was statistics on a temporary table. And this poor execution plan was causing multiple blocking locks, waits, and high I/O and high CPU. So with the statistics on this temporary table, the optimizer was making some decisions about what it thought was in these tables during runtime. The reality was that the number of rows was not accurate, and so it was making a decision about the execution plan that was false. And then we found out later that a DBA had improperly scheduled a statistics update job, and what it had done, it had gone in and it had generated stats on all of the objects in the database. So, again, with the temporary table and the stats, we want to make sure that we're getting this dynamic sampling. We want to see the tables at runtime. So our solution was that we dropped the statistics on the temporary tables, and the execution plan reverted back to the previous plan. The result was that the response time went from several minutes with blocking, locks, and waits to sub-second response times, hardly even worth noting. Our third case study. Oracle Financials. So the complaint, now I have to say something about these complaints. These are the complaints that we get, right? I'm sure you're familiar with this kind of thing. It's kind of a generic, how do you begin to approach these complaints? I mean, this is sort of a generic problem. They're not telling you that the statistics need to be updated. They're telling you that it's just running slow. So the complaint here was that the month-end reporting was taking days to complete. They had to actually schedule it through the weekend. They had to eliminate any interaction with the system until it was complete. We started looking into it, and what we found was that this concurrent process was spawning multiple child processes, and each process was executing full table scans and index skip scans. The reporting process was actually taking about 17 hours to complete. So our solution was to add an index on the particular table in question to eliminate the full table scan, and then we registered that index with a histogram, and we turned off logging, and then we forced the better index in order to get rid of that skip scan with stats update. And the result was that even with a 5% increased execution, the 17-hour report began returning in less than 3 minutes. So SQL-coded indexing can make a huge difference. Case study number 4 is an Informix Java Silverlight, and this is a unique problem. They had this alert in their application. The business rule was they want to see any shipment that was not received within the past 10 days. But they had this alert that wasn't working. From their perspective, it just didn't do anything. I schedule it, but it just doesn't do anything. So we started profiling everything. And again, we profiled from the application level all the way down. And we found that the SQL code was the problem here. And in this particular case, the SQL execution was selecting too much data. The alert actually was looking back 6 months to verify that a shipment should have been received within 10 days. So it didn't match the business purpose. There was no filter that would limit the data selection to 10 days. So the SQL code had no way of limiting the selection against all of the rows of shipment data. Therefore, it was timing out, and the user didn't see this. They just never got their alerts. But it was actually timing out on the back end, and essentially, from their perspective, it wasn't working. So the solution was simply to add a condition to the SQL that would limit the data selection to 10 days. But the more we talked about it, the more we thought, it would be better if the user could make a decision about what they want to see. Maybe they want to look back 30 days, 15 days. So it was finally decided that we add a UI feature, a little menu that the user could then select. I want to look back 5 days. I want to look back 10 days, 15 days, back to 30 days, and allow them to define how far back they want to look. So the result was that the alert began working because the response time went from timing out to sub-second response times. All of a sudden, they had the alert. So not only did they have the alert, but then they had a new feature. Right, so this is kind of one of those treasures that you find and you deal with it reactively, but then you also deal with it proactively because you're not only dealing with the problem to fix it, but you're adding enhancements to improve it for later. Case study number 5 This was a particular billing and processing company. They had this Oracle and Java concurrent program that was running. The complaint was that the billing invoices were backing up, but many were failing. So the more we looked at it, we added hardware, we added memory. We did all these things, but it made no improvement at all. We contacted the vendor, and they couldn't give us any patches or any improvements or any changes that would make it better. We started looking at the SQL code. Again, we started looking at what was executing through this process. We found that the execution plan was subpar. It was selecting the wrong indexes for optimal performance. It was performing index skip scans and index range scans. So what we did was simply add some new indexes that provided the highest degree of selectivity over the current indexes that were being utilized by the optimizer. The result was that the throughput doubled. So they were able to double their billing, and it eliminated the failures due to timeouts and response times. So we've talked about this 5S approach. We've talked about SQL code. We've talked about statistics. We've talked about space and indexing, looking at sessions, looking at scheduled processes. And again, this is a mindset. This is something that is a people-process-oriented approach. And, we have to remember that we can't make assumptions about what we see. In order for us to really find the root cause, we have to begin to really dig down into the code and see what's actually executing on the server. Because it really falls out like this: SQL code, execution, the objects that it's addressing, and the data itself. And so this breaks out really into these 5 areas, this 5S approach. So what are the benefits beyond just knowing what to do first? What are some of the benefits of this 5S approach? We get to root cause faster. We at least know where to look first, right? There's a greater degree of insight on the other end. There's no voodoo. I've always said that if it can be measured, it can be understood. There is a difference in complexity and being complicated. With complexity, we can understand and measure what it is. With complicated, oftentimes it just needs to be simplified. If it's complicated, it needs to be debugged, measured, and simplified. Why is it complicated? We have to ask these questions. So on the other side, we have this greater degree of insight as to why we have these problems. There's no voodoo. There's a measured response, and it can be understood. We're eliminating all of these other distracting possibilities. And again, these things that we talked about before that were symptoms, we don't have a cure for the common cold. We have to deal with the symptoms. But if we are making assumptions about our environment, many times it's like we're treating the common cold. We're dealing with the symptoms, but we're not dealing with the root cause. And so if we can eliminate all of these distractions, all of these other symptoms, then we can get down into the really nitty-gritty of where the problems are. We save time and we save money. There's better utilization of resources, of people and hardware. Remember, the way that we want to approach tuning, we're going to have tools. We need to have tools. And there are good tools and there are average tools. However, tools are tools. We need people, and people need to have knowledge. And people that have knowledge need to have an approach. So it's people and process oriented. And we need to learn to make better use of these resources. This 5S approach works both in reactive and proactive situations. The outcome provides a measured response. And then, of course, because it's measured, our root cause reporting is a whole lot easier. So we're talking about the knowledge that we have, taking the knowledge, creating the right approach, understanding that our approach can really determine our outcome. Our approach really has a lot to do with the presuppositions that we make, and we have to be careful. You know, if I can borrow from the great pragmatist John Dewey, you know, he said we have to suspend belief. You know, and then we engage in this rational discourse. You know, his view, I think, is applicable here. So, you know, if we just wait, let's look and let's make sure that we know all the facts before we make a determination. Let's look at the SQL code. Let's look at the statistics. Let's look at the indexing and how the space is utilized. Let's look at the sessions and schedule processes, and then let's make a determination about what we need to do. What's our action plan? So let me leave you with just some thoughts and really a challenge here. I would challenge you to think back over your career, consider all the problems that you've ever fixed in a production or a non-production environment, and see if this approach applies. See if you have found, just like these other young DBA, the way he found that most of his problems potentially are going to be in SQL code, are going to be in indexing, are going to be in architecture. See if this approach would help you, and it might have helped you then, and it's very possible that you are addressing things from this perspective now. So are there any questions? I have a little time, and it looks like we're finished a little early, so we can have a little healthy discussion. Hopefully I can answer whatever questions you might have.
Thank you, Chuck, for that excellent presentation. Moving on to the questions, we do have some, and the first question is, how is the 5S approach applicable in a live performance issue throughout the cluster at an instant of time?
Okay. So if I were dealing with an instance, if I were dealing with a cluster, and I had a problem, and assuming that I had a tool like OEM that would help me, I would be able to, my first goal would be to, I would ask the question, what is executing? Are there particular SQL statements that are executing in this environment that I could capture, and then I could really drill down into and debug? And a lot of times what I do is I don't necessarily go to the peak if I'm looking at a tool like OEM or, some other type of tool like Toad where I'm kind of monitoring things. I don't necessarily go right to the peak. I might go just before the peak because I want to see what was happening just before I started having these problems. And then I might combine that response or that issue with looking at the sessions and looking to see what else might be running and really begin to dig down into what those problems are and then begin to apply the SQL code, the statistics, the indexing, the space, then begin to look at it from that perspective.
Understood. Thank you, Chuck. Another question, how long does the 5S process typically take?
That's a good question. It really depends on the complexity of the environment. If the problem is, let's say that we come across a SQL statement that's only about 500 to 1,000 lines, it might generate a relatively complicated or relatively complex execution plan. That might take a couple of hours. You make some decisions about indexes. You might first try to update some statistics to see if maybe that changes the plan, and all this time you're testing in some type of environment that's comparable to a production environment, right? You want to make sure you're always doing that. I've seen customers' environments where they have a production environment, but they don't have some type of QA or pre-production that compares. And so sometimes we're testing things and we see different execution plans. So it could take 1 or 2 hours. If it's complex, sometimes it's seeded code. Sometimes it's code that belongs to the vendor, and it could be 6,000 lines, and it could take a couple of days. You're digging down into views or other store procedures that procedure call, And, it's sometimes like, going down into the rabbit hole. And you're really looking for issues like skip scans, range scans, other things that would really be bottlenecks. Once you get to correct these, circle back around, run your explain plan, see what kind of response time you're getting, and then you can kind of make better determinations as to whether or not you're really fixing the problem or not.
Thanks, Chuck. Our next question, what is the most common mistake you see when performance tuning?
Probably the most common mistake I see is a mistake that I make even today. I listen to the people, I listen to the DBAs that know the environments, and sometimes they are making assumptions, and I take them at their word. And here's what I mean, here's what I'm implying. Not that people who know their environment, but many times they might be making assumptions. And so we have to be careful that we're not assuming and making, we're starting with presuppositions that might be false. So I think one of the biggest mistakes I see is that there are assumptions made about the environment. Well, we just installed this new SAN drive, and all of a sudden now it's giving us this response, and we're having these problems in production. That could very well be it. But, you might not have known that development pushed out some new code, and that really is where the problem is. So I would say, making assumptions about where the problems are would probably be one of the biggest mistakes.
Understood. Thank you. Another question. Does the 5 S's approach follow industry best practices?
Well, it does. And here's the thing, I think, for me, it really leads to and promotes best practices. It in and of itself maybe is not, unless we just were to say on our own, hey, this is a really good practice. It does lead to best practices because it is a measured response, because it is an approach, because it's a process that we can apply and really begin to investigate the issues.
And as a follow-up question, Chuck, does this approach apply to all platforms out there?
I would say that this approach would apply to relational databases. I've not actually tried to, overlay this approach in a MongoDB or a Cassandra or a Hadoop type of database. And most of these environments are so new that we're still kind of learning where the performance problems are and learning the issues as we go. And so, I would really say that this is mostly a relational database approach. And so, it would work in SQL Server, Informix, Oracle, DB2, MySQL, most relational database environments.
And another question, one of the attendees is curious to know the source of these statistics that were presented during the presentation. Okay, which slide? There were, I guess there were a couple of slides. One slide had statistics on particular companies, and that was, what I'll have to do is I'll have to go back and find those, because there was a Gartner group. I've gathered some statistics from them, and there were a couple of other places that I gathered those statistics. So what we can do is we can make those available after. Is that possible, Stephen? Absolutely.
Okay, great.
We can definitely do that. Another question, Chuck, what do you view as the biggest challenge to maintaining optimal database performance today?
Maintaining optimal performance, I think, is really an ongoing process. And, it's kind of one of these things that you have to continually cycle and circle back around. So one of the things that we've done for some of our customers is we run daily reports. And so we're looking at the environment. We're looking to see what type of concurrent programs are running. What are the scheduled processes looking like? How are they performing? Let's look at the top 10 poor performing SQL statements, and let's see if these things are items that I can hand off to a DBA and let them work through these problems. Looking at other issues that are, as I described, symptoms of bigger problems. Monitoring these things and then making sure that we circle back around on a continual basis. But you want to make sure that you have a measured approach, that you're managing things from a particular process, and you're relying on the people to do the work. I think it's an ongoing thing, and I think it's a matter of having a measured approach. And many companies tend to focus just on putting out the fires. If we could just deal with these issues and get beyond these major problems, then we can, implement X or do this better, next week or next month. And, sometimes that never happens.
Understood. That is all the time we have for questions today. We apologize that we were unable to get to all the questions, but as I stated earlier, all questions will be answered via email. I would like to thank our speaker today, Chuck Ezell, Senior Applications Tuner, Datavail. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived. Plus, you will receive an email tomorrow once the archive is posted, normally within 24 hours. If you'd like to learn more about this topic, you can download the white paper that Datavail has provided in the resources section. You can also check them out at their website, www.datavail.com. As we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is Daryl Deck. Daryl, please stay tuned. We will get in touch with you to send you your gift. Thank you again, everyone, for joining us today, and we hope to see you again soon.